Having learned how to resolve vectors into mutually orthogonal directions, which act independently of one another, we now take up the subject of particle equilibrium. When we discuss particle equilibrium, we are referring specifically to force equilibrium, namely, sum of the forces as vectors equals 0. As it turns out, the vector sum of all forces acting on an object are required to be 0 if the object is in equilibrium, whether the object is a particle, that is, zero-dimensional or a size that's negligible or inconsequential, or whether the object is a body, that is, the size is important. If the object is a particle, force equilibrium alone is sufficient as it corresponds to translational equilibrium. If the object is a body, rotations must also be considered, and the translational equilibrium equation must be supplemented by a rotational equilibrium equation. Consideration of rotational equilibrium requires us to introduce some additional concepts that we'll discuss in Chapter 4. For now, we consider just particles and translational equilibrium. Because each mutually orthogonal direction acts independently of the others, this vector equation is typically written in 3D as three separate scalar equations, namely, the sum of all the x-component forces must be 0, and similarly all the y-component forces and all the z-component forces must separately sum to 0. Within these equations, each term is typically written as a yet-to-be-determined magnitude on a known direction. For example, we could write f1x as a magnitude we do not yet know on orientation that we do know. This in turn results in a set of simultaneous algebraic equations in the yet-to-be-determined force magnitudes. Proficiency in solving sets of simultaneous equations is an important skill, whether you do so by hand, with a calculator, or with some other software utility. Even if you use software to generate the solution, it is important to be able to write meaningful force component equations in each direction and to recognize when a unique result can be obtained or when the equilibrium equations must be supplemented by additional information to obtain a solution. In most of our illustrations, the set of simultaneous equations will be sufficiently small, 2 or 3 simultaneous equations typically, that you should be able to easily solve the system by hand. Proficiency in algebra is therefore expected in addition to proficiency in geometry and trigonometry. With that in mind, we'll now take up the subject of particle equilibrium.